Hi everyone, it's Mrs. Parr again. Nice to be with you again. We're going to start today's session by looking at the practice activity from the previous session. So here's the practice activity that you were left with after your last session. Now it looks like there are some really big numbers on here, but I know that we've been working on for the last few sessions a really useful generalisation. Okay, do you think you can remember that one? We've used it a lot, haven't we? Okay, so we know that if we change the order of the addends, the sum remains the same. Now we haven't got a sum on here, have we? We've just got number sentences that are equal to each other. So we know we need to just change the order of the addends. So let's have a look. Let's have a look first at this one. In this number sentence here, we have 3 add 4 is complete on that side. So what must our missing number here be? If we've got 4, they match, don't they? So we need to have here, that's right, we need to have a 3. Well done. Okay, so we're just going to use that rule every time now. So here we have our 30 and our 40 on our complete side. And here we've got 40. So here we need, well done, we need 30. Oh, sorry, not drawn very well. Okay, and on this last one down here, this time we've got 400 and we've got 300. Wow, really big numbers. But we don't need to calculate, we just need to find the pattern. Okay, so which number is missing? Can you spot which one we've got? Good, we've got the 400, so we need in here to put the 300. Let's see if I can write it that small. Okay, good. Good, so we've got them complete on this side. Now on the other side, here, we have our missing numbers in different places. Did you spot that? Here, they were all in the same place. Here, there's one missing here, there's one missing here, there's one missing here. Can we still use our same generalisation? We can, can't we? It just has to be balanced. It has to have the same value on each side. So let's have a look. Okay. So here on this complete side, we'll look here first. It gives us more clues. We have 4 add 2 equal to 2 add. Good. Our missing number must be 4. Excellent. Let's have a look at the next one. Here's our missing number this time. So I'm not going to look over here. I'm going to look here first on our complete side. We've got 2 plus 14 this time. And over here we've got a 14 already. So what's our missing number? Has to balance. We're just changing the order of the addends. So we need a 2. Good, well done. Okay, and the last one down here. Sorry. The last one here on the complete side, we have 2 add 24. Excellent. So what's missing here? There's our 2. Well done, everyone. The missing number here is 24. 2 tens 4. Excellent. So in this session, we're going to carry on thinking about our sum and our addends, and that our addends can change order and that our sum stays the same, but we've got a special sum today. We're concentrating on just one special sum. Can you see what number it is that we might be able to concentrate on? Our friend on the screen might be able to help us. Can you see it's number 10, isn't it, from number blocks? There's our number 10, and today we are going to think really carefully about the sum 10. So there are some other number blocks that have come to join us. Now they're the same height as number 10, aren't they? They look different. There's 2 blocks together, sitting one on top of the other, and they still are the same height as number 10. Okay, so they are equal to 10, aren't they? But should we see what the addends would be to make our number 10? Let's have a look. One's jumping down. It's number 1 and number 9. So we know that when the 1 was on the top, it was equal to 10. So what can we tell? Can you think of a number sentence in your head? 10 is equal to 9 and 1, or 1 and 9. It doesn't matter what the order of our addends are. Okay, let's look at that in another way. Oh, here we go. We've got a rhyme. Sorry. We're on the moon, 9 and 1. That was easy. This is fun. Okay, now we've got a tens frame. We're going to do exactly the same thing with our numbers on our tens frame. So first of all, we want to put our 9 on our tens frame. Can you think what that might look like on our tens frame? Can you picture it in your head? So first of all, we've got 5 red counters, but we need some more, don't we? 5 and 4 is equal to 9. There we go. Just got one little space left for our 1. Our other colour counter is 1. Can you have a little think what the cherry model might look like for this? There you go. Our whole is 10 and our parts or our addends are 1 and 9. So we've got number 10 again here. There he is. And we're going to see what blocks are going to come and help us this time. There we go. We've got 2 blocks that are equal to 10 there. Again, shall we see what happens when he jumps down? There we go. Number 2 has jumped down and they've left us there with octoblock number 8. So we know that 10 is equal to 8 and 2 or 2 and 8. Shall we have a look at the rhyme? We're on the moon, 8 and 2. How did we get here? Haven't a clue. Now can you have a think about what the tens frame might look like? There's our empty tens frame. 5 across, and we'll need a few more to get 8, won't we? There's 5 and a few more, but we've got that space for 2. So 8 and 2 is equal to 10. It's filled up our tens frame. Think about our cherry model. What's our whole? Good, it's 10, and 8 and 2 are our parts. Well done. Here's number 10 again. I wonder if anybody can guess what our next blocks might be. On our first slide, we had 9 and 1. On the second one, we had 8 and 2. I wonder if any of you can predict what's coming next. Anybody know? I bet lots of you got that right. So we've got block number 3 has jumped down and it's left my favourite behind. Don't tell the others. Here we have number 7, all the rainbow colours. Number 7 and number 3 were equal to 10 when they were standing on top of each other. So 10 is equal to 7 and 3, 3 and 7. We're on the moon, 7 and 3. We're so lucky. Look at me. Here's our tens frame, ready to fill it up. There we go. 5 and 2 more is 7. And our space for the 3 yellow ones. Good. I bet you're really good now at guessing what the cherry model is going to look like. Have you got it in your head? There it is. Well done. And we could swap these over, couldn't we? We could swap the 7 and the 3 could be in different places. It doesn't matter because when we change the order of our addends, the sum remains the same. Number 10's back on the screen on his own. Again, some of you might be able to predict what's coming next. We had 9 and 1, 8 and 2, 7 and 3. Who have we got? We've got 6 and 4, haven't we? So 10 is equal to 6 and 4, 4 and 6. We're on the moon, 6 and 4. We really couldn't ask for more. Here's our tens frame. What's the 6 going to look like? 5 and 1 more, well done. And we've got the space to fill up the 4. Our tens frame is full with 6 and 4. There's our cherry model. So we've got one more combination of two numbers that are equal to 10. Can you think of one we've missed out? It's the one that our hands helps with as well. Can you guess? There we go. We've got two that are the same. Two number blocks that are the same. What number must they be? That's right. 5 and 5 is equal to 10. We're on the moon, 5 and 5. We sure feel great to be alive. And our tens frame is nice and easy. We've got 2 rows of 5. So a row of red and a row of yellow. Good. And here's our cherry model. Now, of course, we could change the order of our addends, but actually we wouldn't be able to tell, would we? Because they would all just be 2 5s. Brilliant. So our hands are another really useful representation for looking at the number of 10 because we've got 10 digits. I'm going to call them all fingers for today. I know that these are thumbs, but it's easier to call them fingers. So we can look at my hands. We've got 5 and 1 more up. They're the ones that I'm wiggling. They're the ones that are up in the picture. And you might be able to see that I've got 4 down, 3 curled up and my thumb there. But it's exactly the same as the picture. So 6 up. How many would I have down then? We can either count them or you can think, what goes with 6 to make 10? It's 4, isn't it? Well done. Okay. So here's our cherry model. 10 is our whole, so our parts must be 6, our fingers that are up, and 4, our fingers that are down. And we can also look at it in a bar model. There's 10. Which side do you think is 6? Well done. There's more on that side, isn't there? 6 and 4. 6 and 4 is equal to 10. So we have our 10 fingers again to help us represent the number 10. So let's have a look. How many have we got up? We've got a whole hand, which is 5. And in this picture, we've got 3 more. So how many are wiggling? 5, and we can count on 8 fingers sticking up. So how many have we got down? What goes with 8 to make 10? Well done, it's 2, isn't it? Good, let's have a look at our cherry model then. 10 is our whole and our parts are 8 and 2. And our bar model really shows us that 10 is equal to 8 and 2. Now, before we go on to the next slide, which is a different representation, maybe you can have a go with your fingers holding up different amounts and have a think, or maybe even draw the cherry model and the bar model to go with it. Or even ask another person in your house to hold up some fingers and see if you can work out what the number bond to 10 would be. So here is one of my favourite representations for looking at the number 10. It's nice and colourful, isn't it? You might be familiar with these. They're pieces of Numicon. We're going to look at what our whole is first. You might be able to see that there are 2 rows of 5. Shall we count just to make sure we know what there is? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You're absolutely right. Our whole is 10. Now it's made up of 2 different colour pieces, so we want to think about what our parts would be here. Now I think it's easiest to look at the small part first here, because we can see it's nice and bright yellow, and I bet you can see that it is 3. Well done. Now we're getting to know our number bonds a bit better, so you might know what goes with 3 to make 10 already. Shall we double check? You might know what the number is, but let's have a look. I can see here 2 rows of 3, which remind me of the number 6. There's 6, but there's one more. So the number is 7. We know that 10 is the whole and 3 and 7 are the parts. 10 is equal to 3 plus 7. Can you think of another way of writing that equation? We know that we can change the order of the addends and the sum remains the same. Why not pause and try and write out the equation in a different order? Have a quick go. So we have another representation here in Numicon. Just have a look and think what you can see. What can you spot in this representation? I bet you've all spotted really quickly that our whole is 10. And it's quite easy to spot one of the parts here, isn't it? Can you see it? Well done. There's a 1, isn't there? Now again, we're getting to know our number bonds quite well, and you might know what goes with 1 to get to 10. Well done, it's 9, isn't it? Can you see that we've got a whole row of 5 on this side, but only 4 here, so 1 less than 10. We take that 1 away, we've got 1 less than 10 is 9. So we know that 10 is equal to 1 plus 9. I know what you think I'm going to ask you to do next, don't you? Can you think of another way of writing the sum, writing the equation? 10 is equal to 1 add 9, so it must be 10 is equal to, have a go at writing it down. Okay, we've got a sort of little game here. We can see that there are how many marbles? Have a look. How many in a row? 5 and 5 is equal to 10. Well done. We're still working with the number 10. So we have a whole lot of marbles here. There are 10 altogether. So if we know that we have 10 marbles altogether, there must be some hidden under the pot. There are 10 marbles altogether. How many marbles are hidden under the cup? Sorry, it's a cup. So over on this side we have 5. So our other part that goes with 5 to get to the whole is under here. Do we know what that is now? Do we know what goes with 5? We've got 10 digits on our hands, 10 fingers. Shall we try? So if there are 5 outside the cup, what must be under the cup? Do you think you know? If there's 5 outside of the cup, there must be 5 under the cup. Well done. Shall we check? Were you correct? I bet you were. Well done, everyone. So here we've got a different number of marbles outside of the cup, so there must be a different number of marbles inside the cup. Shall we just check how many marbles we've got here? You have a count and then we'll check together. I wonder how you saw them. Did you maybe see 3 here and 3 here? Or maybe 4 here and 2 here? Should we count them in ones just to check? 1, 2, 3, 4, 5, 6. So we have 6 marbles outside of the cup. How many under there to make 10? 10 is made of 6 and... Some of you might know, but we can also use our hands. 6 and... How many fingers have I got here? 4. Let's check. Were you correct? Did you work out that there were 4? Well done, I bet you did. This is a game that you could play with lots of objects at home. You could play it with 1-penny pieces, 1-penny coins, or with beads, or bits of Lego, or anything you want to. Just make sure you start with 10 and you hide some under a cup. And then you could play the game with somebody in your house. So now we're going to practice a chant that helps us to remember our number bonds to 10, our pairs of numbers that go together to make 10. Now this chant was taught to me by a teacher from Shanghai called Grace, so thank you for this, Grace. If you practice this at home, this will really help you to remember which numbers go together to make 10. Are you ready? We start by clapping. 10 is made of 10 and 0, 0 and 10. 10 is made of 9 and 1, 1 and 9. 10 is made of 8 and 2, 2 and 8. 10 is made of 7 and 3, 3 and 7. 10 is made of 6 and 4, 4 and 6. 10 is made of 5 and 5. So as well as practicing your chant, we've got another activity for you to do for practice after this session. What we'd like you to do is get some pieces of paper and you're going to write the numbers 0 to 10 on your pieces of paper. You will need 2 cards with the number 5 on, okay? Then you're going to place all the cards down on the table so you can't see the number, face them down. And then you're going to play pairs, really. You're going to turn over 2 numbers and see if they are the numbers that go together to make 10. If they are, you can put them together. If not, turn them back over and have another go. Okay, I hope you enjoy the activity. See you soon.